Full-scale structural and non-structural construction procedure of a multi-storey test building at the Anglekirk Structural Engineering Shake Centre. Module 1, Structural General Overview. Objective 1, to provide an overview of the conventional strategies of construction for a cast-in-place foundation. Objective 2, to provide an overview of strategies used in preparing and installing conventional rebar and high-strength post-tensioning tendons for cast-in-place construction. Objective 3, to introduce the basic phases of construction of cast-in-place columns, beams, shear walls and floors. Objective 4, to provide an overview of falsework and scaffolding for cast-in-place construction. Typical foundation structures are built below ground. Because this experiment was conducted on a shake table, the foundation was constructed above ground. Therefore, some differences from conventional foundation construction practices will be highlighted in this video. One of the most apparent differences between the 5-storey building case study and footing construction in conventional buildings is that the test building was constructed directly on a shake table, also called a steel platen, rather than on the ground. This table, found at UCSD, is an outdoor shake table with a one-direction axial loading feature. Missing in this video is the initial step of excavating the earth in order to place the foundation into the ground. When constructing a specimen on a shake table, a test structure is cast directly only to the top of the steel platen, requiring formwork to support the side walls of the foundation. In the field, however, shallow footings can make use of the natural side walls provided via the excavated earth, but formwork in the field is required if the side wall of the foundation extends above the natural grade or ground level. Depending on the design of the foundation, the formwork may often require both an interior and exterior segment to support the structure of foundation components. In this particular case, the interior formwork segment was installed first. After completion of the interior formwork, the exterior formwork of the foundation is constructed. Unlike traditional building construction, box elements were fabricated at each edge of the foundation to block the concrete from filling the space where base isolators would eventually be installed. Base isolators are used to dampen the shaking of the structures when seismic forces are applied to them, and consequently to reduce the damage to structural and non-structural components of the structure. After the construction of the foundation formwork is complete, steel reinforcing bars, simply termed rebar in the field, are installed. When a concrete section is reinforced with steel rebar, it is termed reinforced concrete. These carbon steel reinforcing bars, which are ribbed to facilitate a strong mechanical interlock with the concrete, are used to increase the tensile strength of concrete, since it is weak in tension. After the construction of the foundation formwork is complete, steel reinforcing bars are connected together in different directions to form rebar cages. Rebar cages provide tensile strength for the concrete in more than just one direction, as opposed to rebars laid at one single dimension. These cages can be built either on or off-site and then placed inside the foundation formwork. In this project, the foundation rebar cages were built on-site. Continuity with the superstructure is facilitated by extending reinforcing steel from the foundation with sufficient overlap to reinforcing steel provided within the structural components, such as walls or columns. In this project, during placement of the foundation reinforcing cage, the reinforcing cage from the columns were placed and extended well into the upper levels of the building. The columns were detailed with a prefabricated welded tie tightly spaced up its height, encapsulating the vertical bars. In many structural applications, high-strength steel rods are used to pre-stress reinforced concrete and ultimately improve the integrity of the structure. In pre-stressed members, compressive stresses are introduced into the concrete to reduce the tensile stresses resulting from applied loads, including the dead load. Pre-stressing can be accomplished either by pre-tensioning or post-tensioning the concrete. Post-tensioning can be done in two forms of bonded or unbonded. In this project, both bonded and unbonded post-tensioning were used. High-strength rods and tendons were placed inside PVC ducts, which were cast within the foundation. The rods were left unbonded and tensioned after placement, while the tendons were bonded with the grout and then tensioned. Once the rebar cages and formwork are completed, the foundation concrete is poured. In this project, the concrete was poured using a truck-mounted boom pump method. Concrete can be used in two forms of precast and cast in place. As the names offer, the precast concrete products are built off-site and then transported to construction site, while cast-in-place concrete products are built at the spot where they're supposed to be located at. In this project, the concrete is poured and hardened on the site, and therefore the cast-in-place method is used. Finally, the concrete is thoroughly covered with a waterproof layer in order to control and keep the moisture content preserved during the curing process. During the pouring process, samples of the concrete are poured into small cylinders, which are prepared for testing various stages of the curing process to assess the concrete strength. After 28 days of curing, the concrete should reach around 90% of its design strength. The next phase of the construction process for this building was to build the shear wall for the elevator shaft. Shear walls resist lateral forces, mainly caused by seismic and wind loads. The formwork used for construction of walls depends on how many sides of the wall require forms, either a single face of formwork or a double face. For this project, the elevator shaft shear walls required double face formwork. Shear walls forms were installed similar to the formwork described earlier for the foundation. Rebar cages were then placed and concrete mix was poured. In conjunction with the placement of the shear walls, the column formwork for the first floor were installed and concrete was poured and allowed to cure. After the concrete had sufficiently hardened, the formwork for shear walls and column were removed. In order to decrease the costs and be environmentally friendly and efficient, many portions of the formwork were reused in the construction of the other portions of the building. Therefore, special care was taken to avoid damage to the forms while concrete was being poured. Samples were taken from the mix inside cylinder tubes to further evaluate the correspondence of concrete strength to the expected value for construction purposes. After completion of the first floor construction, the fabrication of falsework is required in order to construct the second and subsequent floors. Falsework can consist of beam clamps, braced frames, timber scaffold tubes, and props. Every time concrete is poured during a construction job, several standard tests are conducted to verify the expected workability and strength of the concrete mix that is delivered to the site. For each concrete truck that arrives on site, a slump test is performed immediately on the side of the job site. A cone-shaped mould is first filled with wet concrete. Then a metal rod is inserted into the top of the cone and pumped up and down 25 times. This helps eliminate air bubbles and increases the homogeneity of the concrete mix. The mould is then removed slowly and placed adjacent to the concrete specimen. The free concrete is allowed to slump down under its own gravitational weight. After the slump settles, the metal rod is levelled horizontally on top of the mould, and the distance from the horizontal rod to the top of the concrete is measured. The change in height of the concrete sample is referred to as the slump for that specific batch of mix. The slump measurement is compared with specified values, and a decision is made to accept, modify, or reject the concrete mix before placing the concrete. During construction of structures higher than 1 story, safety measures in the form of scaffolding must be provided for workers. In accordance to the Occupational Safety and Health Administration, known as OSHA, scaffolds of at least 18 inches wide must be provided as a walkway for workers, and they should be at least 10 feet away from power lines. Scaffolds must remain completely planked platforms, equipped with safety guardrails on all open sides, and be tied properly to the building. If a scaffold is more than 10 feet above ground, workers must have fall protection. For construction of this multi-story building, all the workers were provided with safety training and fall protection. In addition, all required occupational safety and health administration regulations and codes were adhered to. After finishing the second floor, the formwork for the shear walls and columns were removed. Because of the repetition of the procedure, system formwork is used for building the rest of the floors to decrease costs and increase the speed of construction. System formwork is made from standard modular components that are assembled like Lego pieces. In comparison to conventional timber formwork, system formwork has better casting quality, more recycle times, and faster erection. There are 2 types of system formwork, jump form and slip form. Slip form usually makes use of its own hydraulic power to lift itself up against previously completed floors and is suited for tall structures where no change in formwork is required. On the other hand, jump form requires a crane to lift it up for each cycle. In this project, jump form was used for the upper floors. Once the second floor was completed, the system formwork was raised for construction of the third floor, where the columns and shear walls were installed. This process was repeated for each subsequent floor. In addition to structural formwork providing access to each subsequently constructed floor level, prefabricated metal stairs were installed at each level to provide access to the upper levels. The stairs are built off-site and then moved to the site for installation. Stairs are installed in 2 phases. During the first phase, the skeleton of the whole structure is not complete, and the stairs connect only the first 3 lower floors. After the completion of the skeleton of the whole structure, the second phase of stair installation begins. Stairs connect the upper 2 floors in this phase. This method is continued